Welcome back to the another session of our data structure journey. Today we are going to cover how to delete an element from the first position of the double linked list. We are already completed insertion of the various category from the last video. So today we are going to cover from the deletion from the first end. So whenever we go for delete, then what are the possibilities we have to cover? First one is the case one when the list is empty. So if there is no element present inside the list, then what happened? Nothing to print. So we have to just print the error message or delete message not possible, and we have to exit. Second case, list have elements but only one element. What happened whenever a single element present inside the linked list? After that, list is empty. So that's why we have to check whether the list have single element or more than one element. If single element, then we have to remove and make the both the last pointer as well as the start pointer as a null. In my previous video, I have already mentioned that there are two pointer we are using, start as well as the last pointer. Start pointer points to the first node, last pointer points to the last node of the linked list. Double linked list means both the direction we can able to traverse. Case 3, list have more than one element. Then we have to remove the first element and make the start node as a next of it. Means the second node we have to make as a start node. So these are the possible cases for the deletion at the first position of the double linked list. So this is the same case in case of single linked list. But here only thing is that we have to make the connection to the backward direction. Otherwise, cases or possibilities are the same as the single linked list. Only difference is that how we make the connection with the pointer for the back pointer as well as the next pointer. So let's take the first case. That is the list is empty, so nothing we have to do. Second case, list have single element, then remove the single element and make the start pointer. So whenever there is only one element is present. So now in this linked list, what happened? Only one element is that is 45 is present. Start point to this same, last also point to the same. That is the address is 200. So single and then remove the single element and make the start as last as a null. Why? Because after deletion there is no. So what are the procedure? Make the start pointer as a 10. So first we have to make the start as a 10. Then we have to make the print the data to be deleted as well as then make the start as well as the last pointer as a null. So this is the step we have to follow. Then another case, that is list have more than one element, means only it is not contains only one element more than one. Then what happened? We have to remove the first element, make the start node as a second node. So let's take an example. So in this example, there are three elements present inside the linked list: 10, 20, 30. Start pointer points to the first node, last pointer points to the first node. As it is a double linked list, both the side link possible. First node, back is null. Last node, next is null. So what are the things we have to do? Make the start as a temp pointer. So here what happened? We have to make the another pointer that points to the starting node. Then we have to print the data, then make the start pointer to the next node. Now we have to make the start pointer as a to next node. So we make the next node. Then we have to free the temporary variable. Then we free the temporary variable. So this is our double linked list. This linked list we are already covered from the our data structure journey of the double linked list. So we are already covered how to insert in the first position. Then display I explain this one video, that is the 5.1. Then next video I completed that insert into the end position. Then I completed insert in any position. Now we have to write down the code how to insert into the first position. So here we have to write down how to insert into the first position. So for example, this is the place where we have to write down the code into the first position. We have to write down the code. So first example, I have to write down the function name. Function name is the delete first because we are going to first position. Function does not take any parameter, does not return any value. So first we have to check whether the list is empty or not. So how to check the list is empty? If start equal to null means list is empty. Then what we have to write down? We have to just print that. Printf. It is our choice what we want to print output screen. So after that, what happened? This is the case one. List is empty and we have to exit. So list. So first case is over. Then second case is that is list have single element. So how to know is a list is a single element? If start next equal to null, then what happened? List is a single element. So we have to write down else if start next equal to null, then single element, then if it is a single element, then what we have to do? We have to store the address of the start in another pointer. So we make the temp. So what is the temp? We have to write down node. So node is a pointer. Node is a pointer to the address of next node, and we declare the pointer variable as a temp. Then we store the start value. Then we have to make the start equal to start next, because here it is print the data to be deleted, make the start as a null. So we have to print the data. So we can write down or printf %d is the or percent is deleted. Now next line is that is make the start as well as the last as a null. So we have to make start equal to last equal to null. Then free the temp means we have to free the memory. So we have to free is the function to release the memory. So this one is the case 2 is over. Then case 3. So there is no case. So we have to write down else. Else what we have to write down? Else make the start pointer as a temp. So we have to make the temp equal to start. Then print the data to be deleted. So say, here we are just make, but we are not mention which data. We have to write down a temp info. In info part we store the data. So we have to write down the temp info. Same thing we have to write down. So I just copy paste. So once we print, then what happened? Make the start pointer to the next node. So we have to write down start equal to start next. So it point to the next node. Then release the memory. So we have to release the memory by help of the function. Okay. So this is our function declaration is over. So right now we are converted the algorithm into the code. So this is our delete first is over. Then so this is more than one element for this is the else part. Okay, so we have to go to the main function to add one more cases as we are did in last video. So this is case 3 insert a specific position. Then case n4 is the delete from start. This is case 4. Then case 5 is display. Then case 6 is the exit. So here one more case we have to add. Case 4 is display. No, this is case 5. So here delete. Let me copy the function, otherwise we will get error message. Delete first. Okay, let us compile. Now we have to go to the run the program. Before deletion, we have to insert the value. So let insert the value 1 0, then 2 0, then 3 0, then 4 0. After that, let display the display is 5 right now. So 10, 20, 30, 40. For example, I have to delete from the starting. So I have to go for 4. 4 is 10. Yes. 10 is deleted. So after deletion, if I go for display, 10 is not present. Okay. For example, again I go for delete. 20 is deleted. Then 30 is deleted. Then 40 is deleted. Now list is empty, deletion not possible. Or we can say it is a underflow condition. So if there is no data, this condition also we call as the underflow. So we can make like this. So this is the way we can delete an element from the double linked list. So here only things you may think that whatever we did is the correct one. But remember, certain things we have to check whether we are performing the things is proper way or not. Because we are doing the double linked list. Double links in both the direction, we have to make the changes. Here what happened, whenever only one element is present, we make the start next equal to start next. But we have to make the start back equals to null. Reason is that whenever we delete the node, the second node becomes the first node. So first node means what? First node backside is there is none, means back there is no pointer previous pointer, so we have to make this one as a null. We got the correct answer because we are traversing from the left to right. So right now we are getting the correct answer, no issue. But if you go for the deletion from any, after that if you go for the insert any value or insert any position, at that time you will get the error message. That's why I just try to rectify all the things. So whenever you are doing the program, don't think whatever you are writing, it's the correct. Little bit changes you require to do it. 3 makes the start pointer to the next node, as well as one more condition we have to add, that is make back pointer back pointer of start as null. So this is our perfect answer. So this is our final code. So here first we have to know what are the possibilities. There are three cases. Case one is the list is empty. If the list is empty, we have to print list is empty, deletion not possible. Second case is that is list have single element, means there is only, for example, this is our linked list, only one element is present. So start point to this one, last also point to this one, and both the side is null. There is no element. So here what happened? So how to check start next equal to null? So we have to make the temp. So what is the temp? Temp right now point to this one. Then percent is deleted. That's the temp info. What is the temp info? So 10. So output will be displayed. 10 is deleted. 10 is deleted. So it will print this value. Then we make the start equal to last equal to null. So previously, what is the value? So for example, this is the 100. So start store which value 100 and last store also 100. So that's why both are point to. So here what happened? We have to make the start as well as the last point to the last store the which value, that is null. So right now start store which value null, last also store the value of null. Then we have to release the memory. So we have to release the memory. So it means that we have to remove the memory. So there is no memory. So after that, what happened? Start equal to last and last equal to null. So both are null, means list is empty after deletion of single element. Then what happened? List have more than one element. So for example, this is the case where number of element is present. Both the direction connection is established. This is start, last. So now English have three elements. Now we have to delete from the first means we want to delete this node. Once you delete this node means what? This side is null, this side also null. So make the temp equal to start. So what right now temp store which value? This value. Percent D temp info. So whatever information it will display that it's going to be deleted, then start equal to start next. What is the start next? Start next is this value. Now start point to this value, this value. Then you have to make the start back because previously, because this node right now store which address? Address of this node. Whenever you make this node as a first node, then what happened? You have to make this node as a null. So you have to make the start back equal to null. Then you have to release the memory. Then we have to release the memory. After that, we are release the memory. So this is the two node and this node points to the null. This is the last node. This is the first node. So this is the way the deletion from the first node is going to be performed. Thanks for watching the video. Please subscribe the channel, share the channel as well as like the channel. Thank you.